Okay, so this is 9.6 or 10.6, finding segment lengths in circles. So we learned a lot about segment lengths and arc lengths last unit or last section, and angle measures and how to find those. So there's really a lot of information in this unit to keep straight, okay? And I'm going to add to that today. So I have two chords in a circle, so this is Theorem 10.14. So what happens here is the product of these lengths, so A to E times E to B, will actually equal E to C times E to D. So this piece times this piece will equal this piece times this piece on any two chords that cross in a circle, okay? So let's try number 1 down below because that goes along with that one. So this is 10.14. So what they're saying is that 8 times x would equal 8 times 10 would equal 5 times x. So that's just 5x, right? 8 times 10 is 80, so 80 equals 5x. To get x, I just divide by 5, divide by 5. So x equals 16, right? Yep, 16. So that's how you use that first theorem. Okay, the second theorem says I have two secants. So remember, a secant crosses a circle at 2 points. So I have two secants and they have the common endpoint. What this one is saying is this piece times the entire length equals this piece times the entire length. Okay? So, number 2 is Theorem 10.15. So 3 times, now the entire length is not x. The entire length is 3 plus x, and it's not 3 times x, it's 3 and then this additional x, right? That is equal to 4 times 4 plus 8 is 12. So you got to be careful on that and add to make your whole length. So I'm going to distribute, and I get 9 plus 3x equals 48. I'm going to subtract 9 from both sides, so I get 3x equals 39. Divide by 3, I get x equals 13. All right, so this one, it looks a little different, but it's back up to 10.14. So why don't you pause me and see if you can try that one and figure it out on your own. So this one is saying, okay, this piece is congruent to this piece. That would also make this arc congruent to this arc. We learned that in a previous section. So 5 times the other piece, 5, is equal to 2 times x. So that equals x equals 2x. This is clearly not drawn to scale. I'm going to divide by 2, and I get x equals 5. So again, not drawn to scale, and that's okay. Okay, go ahead and pause me and try, well, actually, I want to do number 4 with you. Okay, so this one goes back up to Theorem 10.15 with the two secants, okay, where you take the smaller piece, that 5, times the entire length. And they actually told us in this situation that the entire length is x. And then I'm going to set that equal to 6, the smaller outside piece, times the whole length of 10. So that's just 5x equals 60. Divide by 5, and I get x equals 12. Now that's the entire length. Let's say that they went ahead and said, okay, that's the entire length, but what is this piece right here? Well, to get just that piece, I would take this 12, the whole length, minus the 5 that we have there, and I'm left with 7. Okay. This one is similar to Theorem 10.16, so we're going to do that together because we haven't done one of those yet together, where I do this top piece, the outside piece, times the whole thing. The whole distance is 27, is equal to this squared, or x times x. So x times x does give us x squared. 3 times 27 gives us the 81. And that's nice because we want to get x squared down to x, so opposite, we do square root of x squared, and we get x equals 9, positive or negative 9. So we actually have two answers there. However, we're talking about a distance. And so in this situation, a distance doesn't make sense, so x actually just equals 9 in this situation. Okay, number 6. Go ahead and pause me and try number 6 on your own. Unpause me when you're done. So I'm going to do outside times the entire length, which remember, that's 7 plus x. It's not 7 times x. Is equal to the outside, which is 8, times the entire length, which is 16. I get 49 plus 7x equals 8 times 16 is 128, I believe. 128. Okay, so I'm going to start solving for x. I'm going to subtract 49 from both sides, and I get 79. 7x equals 79. I hope I haven't had a mistake here. I don't think so. Okay. And then I'm going to divide by 7 on both sides, and I get 11.29 rounded to the nearest hundredth. Okay, next page. Go ahead, and I want for you to try all of these on your own to see how well you do on them. So pause me, try them, unpause me when you're done. When you get down to 10 and 11 and even 9 and 12, 9 through 12 may be a little more difficult. It may bring in some algebra. Okay, so this one would just be 6 times 10 is equal to x times x plus 7. So this is 60. I'm going to distribute equals x squared plus 7x. This actually brings in some algebra too, because if you see we have an x squared and an x, and so we can't solve something or this just by solving for the x. So we actually have to get everything to one side, so I'm going to subtract 60 on both sides. So I get 0 equals x squared plus 7x minus 60. And this should bring you back to your algebra concepts, because it's a quadratic. So the way I teach quadratics is I teach them by crisscrossing. The number I want to multiply to is that negative 60, and the number I want to add to is 7. So I need to find two numbers that multiply to negative 60, but those two numbers also have to add to 7. So this becomes really difficult if you don't know your factor pairs. So what times what equals numbers. So this would be 12 and 5. 12 and 5 makes 60, and some combination of 12 and 5 will give me 7. That would be a negative 5. So that means that 12 times negative 5 gives me that negative 60 that I want, and 12 minus 5 equals 7. So it factors into x plus 12 and x minus 5 equals 0. However, we're not finished yet, because what you do then, you still have to solve for x. So you set each equal to 0. So you subtract 12 from both sides, so you get x equals negative 12, and you add 5 to both sides, so you get x equals 5. Well, 5 and negative 12, there's only one that's an answer, and it's this 5, because we want the positive and not the negative, because this is a distance, and distance isn't negative. All right, next one. We're going to do 8 times 8, which is 64, equals x times 2 x's. Okay? So I'm going to distribute. So this is, and I know that this is x, right? Because that's saying that's equal to that. So it'd be x times the whole whole distance. The whole distance is an x plus x, which gives us 2 x's. So when I distribute that, I get 2x squareds. So now I'm going to start solving for x. So I divide by 2 on both sides. 64 divided by 2 is 32 equals x squared. Now to get x down to just, or to get x squared down to just x, I square root that. That will give us a decimal. So I get x equals a positive and negative, but the negative doesn't make sense in this situation. 5.66 rounded to the nearest hundredth. All right, next one. This piece times this piece equals this piece times this piece. So x times 3x minus 3 equals 2x times x plus 6. So now I need to go through and I need to distribute. So I get 3x squared minus 3x equals 2x squared, what is that, plus 12x. So guys, this is a lot of algebra. So hopefully you're remembering some of these. I'm going to move everything to the left, so I'm going to subtract 2x squareds and I get just x squared. I'm going to subtract 12x, and that gives me negative 15x, and that equals 0. So I have an x squared and an x here, but I don't have a third term. I don't have a constant. And also these have a GCF, something I can take out, and that is x. When I take out the x, I'm left with x plus 15. And this is actually its factored form. So at that point, I set x equal to 0. So you set this guy equal to 0. But then you also set that x minus 15 equal to 0. There's nothing I need to do here. X just equals 0. But here, add 15 to both sides, and I get x equals 15. Well, 0 doesn't make sense for a length, but 15 does. So 15 would be my answer there. Next one. 4 times 4 plus 2x is equal to 3 times 3 plus 3x plus 1. Okay? Remember, you take the outside times the whole length, outside times the whole length. That gives me 16 plus 8x equals 9 plus 9x plus 3. 9 plus 3 is 12. So I'm just reducing that down. Combine like terms, same side. So now I'm going to move the 8x this way to get me 1x over there. I'm going to subtract 12 here to give me 4 over here. And now we have x, and x is equal to 4. All right, 2 more, guys. All right, this piece, x plus 2 times the whole distance. I'm going to go ahead and add it as I do this. So that would be 3x minus 6. That is equal to x plus 1. And then I'm going to go ahead and add it. That gives me 3x minus 4. So first thing you need to do on this is multiply and distribute. So first, outside, inside, last. That gives me 3x squared minus 6x plus 6x minus 12 equals 3x squared minus 4x plus 3x minus 4. I'm going to combine my like terms. Those actually cancel each other out, so I'm left with 3x squared on this side minus 12 equals 3x squared on this side minus x minus 4. I'm going to start moving stuff together. So I'm going to subtract 3x's from both sides, and what you'll notice is that those actually just cancel out. And so I am going to also move this negative 4 over to this side. So that gives me, so I'm going to add 4. That gives me negative 8 equals negative x. I'm going to divide by negative 1 on both sides, so I get x equals 8. All right, one more. All this algebra, one more. All right, 5 times 5 plus 3x equals 8 times 8 plus x plus 2. So distribute 25 plus, oh, that pen's not working. 25 plus 15x equals 64 plus 8x plus 16. Combine like terms on this side and I get 80. Plus 8x equals 25 plus 15x. I'm going to subtract 8x on this side, so I get 7x. And I'm going to subtract 25 on this side to give me 55. Hopefully I've done all my math here correctly. Divide by 7. And I get x equals 7.86, rounded to the nearest hundredth. Okay, so 2 things. There's going to be a homework assignment over this section, and then I also would like for you to do this 10.4 through 10.6 review. It is, I think, 3 pages, front, back, front. And then put in the selected answers into Schoology. All right, thanks, guys.